Hey friends, this is Ratios Day 19, more changing ratios problems. This is our review before the quiz tomorrow, so hopefully you guys are doing well in changing ratios. Today's going to give you a little bit more practice. So our first problem is, in a choir, the ratio of boys to girls is 3:1. Later, 40 new members joined the choir, and as a result, there were 3 times as many girls and twice as many boys as before. How many members were there at first? Okay, let's start with our situation in the before. So we have the ratio of boys to girls is 3:1. Let's go ahead and model that. We've got 3 units of boys and 1 unit of girls. It says later 40 new members joined the choir, and as a result there were 3 times as many girls and twice as many boys as before. So let me go ahead and change my ink color here. We'll go with purple. Okay, I'm not going to quite deal with this quantity yet. Let's deal with the new ratio. It says there were 3 times as many girls, so that means that 1 times 3 is 3. So girls are going to have 3 units in the after situation, and twice as many boys. So, 3 times 2 is 6. So my boys are going to now have 6 units, and my girls are going to have 3. Okay, now let's go back here and deal with this quantity. It says 40 new members joined the choir. So obviously, those 40 new members are going to be split between these units and these units. Okay, so since I have 5 new units, I can just go ahead and solve this now. So 5 units is 40 members. So that means 1 unit is 8. Or 40 divided by 5. And we want to know how many members were there at first. So, since 1 unit equals 8 people, I want to go back here and I want to figure out how many people I had at first. So I'm going to solve for 4 units. So 4 units is going to be 4 times 8, which obviously is going to equal 32 people at first. Okay, let's try another one. All right, so the number of Gabby's Oreos is 1/4 the number of Hunter's Oreos. If Gabby gives 1/2 of her Oreos to Hunter, what will be the new ratio of Gabby's Oreos to Hunter's? Okay, well, let's see. What are we starting out with? We've got Gabby with 1/4 of Hunter's Oreos. So let's model that. So we've got Gabby and we've got Hunter. So obviously Gabby has 1 and Hunter is going to have 4. Okay, then it says if Gabby gives 1/2 of her Oreos to Hunter, what will the new ratio of Gabby's Oreos to Hunter's be? So both of my quantities are changing, aren't they? Because Gabby's going to take some of her Oreos and she's going to give them to Hunter. But we can't really take half away from Gabby right now because she only has 1 unit. So we need to subdivide. And we don't just subdivide one part of our ratio, we have to subdivide both parts of our ratio. So now we can take away part of Gabby's, and we're going to give that to Hunter. So let's add 1 to Hunter's. And it says, what will be the new ratio of Gabby's Oreos to Hunter's? Now we can answer this, can't we? Gabby now has 1 unit where we want Gabby to Hunter. Gabby has 1. Hunter now has 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's the answer. All right, I bet you can do this one on your own because it's very similar to one that we just had yesterday. Just remember to read the question carefully and make sure you answer the question that's being asked. So finish the problem all the way to the end, and then come back and check your work. All right. So Micah earns $2,000 a month. He spends part on food, rent, and transportation in the ratio of 2 to 5. To 4. if he spends $300 less on food than rent, how much does he have left for savings? Okay, well, since he's got 3 more units of rent than food, those 3 units must equal $300. And we want to know how much he has left for savings. But let's see first how much he spends. So if 3 units equals $300, 1 unit equals 100. Now let's figure out how much he spends. He spends 7. Let's see, 2 plus 5 is 7, plus a number 4 is 11 units. So 100 times 11 is $1,100. Okay, that does not answer our question, does it? Because our question is, how much does he have left for savings? Well, if he earns $2,000 a month and he spends $1,100 a month, we're just going to find the difference. So we're going to subtract 1,100 from 2,000, and he saves $900 a month. All right, check it out, guys. Another drain problem. So some workers were digging a drain. The ratio of the length dug to the length not dug was 5 to 4. After another 30 meters had been dug, the ratio became 7 to 2. What is the total length of the drain to be dug? Okay, so for me, again, it's easier for me to visualize this kind of problem drawing a model that actually looks like a drain being dug and then dividing that up into units. So it says that the ratio of the length dug to the length not dug was 5 to 4. So that means we've got 5 units at the top here that are already dug and 4 units at the bottom here that are not dug yet. So those still have dirt in them. Then it says after another 30 meters had been dug, the ratio became 7 to 2. What is the total length of the drain to be dug? So when we look at this, we've got 5 units that are not dug and 5 units that have been dug and 4 units that are not dug. So obviously they're just going to be digging down deeper, right? So what happens if I just keep digging? What happens? Okay, now look, oops, I erased too many lines there. So check it out. I just dug 1 more unit deep, and now I have a ratio of 6 to 3. That's not quite right yet, is it? Now what happens if I dig 1 more unit down? Now I have a ratio of 1, 2, 3, 4, 5, 6, 7. 7 dug and 2 not dug. Well, that's kind of cool. Now I'm at the right ratio. So I just dug down 2 more units, didn't I? And then it says after another 30 meters had been dug. So those 2 units that I just dug must equal 30 meters. Well, now I have something to go on. So if 2 units equals 30 meters, 1 unit is going to equal 15 meters. We want to know the total length of the drain to be dug. So we're going to solve for all of those units. So 9 units equals 9 times 15. And let's work that out over here. A little calculator over here in the corner. 9 times 5 is 45. 9 times 1 is 9, plus 4 is 13, and we get 135 meters. All right, next one. Oh, look at that, I already have a graph. Okay, the ratio of the number of boys to girls in a school hall was 8 to 3 at first. Then 45 more girls joined the pupils in the hall, and there was an equal number of boys and girls. How many children were in the hall in the end? Okay, well, I've got my before situation modeled already here, so I've got 8 units of boys and 3 units of girls. Then it says 45 more girls join. So no boys are going to join, right? And then there was an equal number of boys to girls. So obviously, girls' units are going to catch up to boys. So if girls have 3 now, they're going to add 5, aren't they? And we know that those 5 units have to equal 45. Now we want to know how many children were in the hall in the end. Well, let's solve using unitary method. So 5 units equals 45. That means 1 unit equals 45 divided by 5, which is 9. And we want to solve for all of these children, which means we need to solve for 16 units, because I've got 8 units of boys and now 8 units of girls. So 16 units is going to equal 9 times 16. And if we work that out over here in our little calculator area, we have 9 times 6, which is 54, and 9 times 1, which is 9, plus 5, which is 14. So we have 144 children in the end. All right, so we have the ratio of height plant X to the height of plant Y, 5 to 3. If plant Y grew 140 centimeters taller, the ratio of the height of plant X to plant Y would be 1 to 2. And how tall is plant X? Okay, let's plan this out a little bit. So we've got X and Y. X has 5 units. And Y has 3. Okay, then it says if plant Y grew 140 centimeters taller, the ratio of the height of plant X to plant Y would be 1 to 2. So what's changing in this problem? Obviously, plant Y is going to grow, but it does not say that plant X grows. So we're going to assume it remains the same height. So plant X should still have 5 units in the after. However, it says that our ratio is 1 to 2. So I need to find an equivalent ratio that's equal to 1 to 2 for my after. So what I'm going to need to do is, since plant X is the 1 and it has 5 units, I'm going to need to double that to get the units that plant Y will have in the after. So it's going to end up with 10 units. All right, so plant X will have 5, plant Y will have 10. So I just added 7 units to plant Y, didn't I? And it said in my word problem, if plant Y grew 140 centimeters taller, then the ratio would be 1 to 2, right? So those 7 units that I just added are going to equal 140 centimeters. So now we can solve this. So let's say 7 units are equal to 140 centimeters. 1 unit is going to equal 20 centimeters, which is 140 divided by 7. I want to know how tall plant X is, so I will solve for 5 units. So 5 units is 20 times 5, which equals 100 centimeters. All right, friends. Our last problem is an interesting one, and I think what I'm going to have to do is continue this in a separate video since I am about at my 15-minute limit here with my free version of Screencaster. So go ahead and stop the video and pick it up on Ratios Day 19, Part 2.